So we're going to review the August 2014 Regent, just the multiple choice here. Okay, so question 1. Which statement is not always true? So this is going to require the memorization of these rules. So product means that we multiply, and sum means we add. Okay, so a rational times a rational is rational. An irrational times rational is irrational. A rational times irrational is irrational. An irrational and irrational times irrational, it can be both, right? So it's sometimes, it's not always. So this word always here is going to be really important. For adding, the rules are pretty much the same. Rational plus rational is rational. Irrational plus rational is irrational. Rational plus irrational is irrational. And irrational plus irrational is sometimes both. So now we can look to see the product of two irrational numbers is irrational. Not quite, because sometimes it's rational. The product of two rational numbers is rational. Well, we have that here, so that looks good. Let's just look at the other ones and make sure. The sum of two rational numbers is rational. That is also true. And the sum of a rational number and an irrational number is irrational. So the sum of irrational and rational is irrational. That's also true. And me reading this question very quickly, I missed. It says which statement is not always true. So since one is not true, that's our answer. Okay, number 2, a satellite television company charges a one-time installation fee and a monthly service charge. The total cost is modeled by the function y equals 40 plus 90x. Which statement represents the meaning of each part? Okay, so just looking at this, so we see a one-time installation fee, right? So because it's one time, this is going to be our constant, right? And our constant has no variable. Okay. And there's a monthly service charge, right? So this is going to be per month. Therefore, it has a variable. So that should help when we read through these options. So y is the total cost. X is the number of months of service. 90 is the installation fee. And 40 is the service charge per month. So we already matched the per month with the service charge with the variable, right? So that means whatever the price is per month, the service charge is going to be with the variable. So that's not 40. So we know 90 is going to be the service charge. And options 2 and 3 say that. Options 1 and 4 says 40 is the service charge, and it's not, because we know 40 is not with the variable. Right, and we're multiplying 90 times the per month. And here we have 90x. So if we are writing 90 per month, x must be the number of months, making 1 our answer. So y is the total cost. Y is pretty much always going to be the total cost. And then make sure you're matching your rate per month with the variable. Okay, number 3. If 4x squared minus 100 equals 0, if it equals 0, the roots of this equation are. Okay, I'm going to show you 2 ways to do this. First, let's do it algebraically. We want to solve for 0 here, so we're going to add 100 on both sides. And we get 4x squared comes down. The 100 and negative 100 canceled out. So that equals 100. And now we're going to divide by 4 on both sides. And we are left with x squared equals 100 divided by 4 is 25. Now we want to get rid of this exponent, so we're going to take the square root of both sides, and we get x equals plus or minus 5. Whenever you take the square root, you need plus or minus. So that is going to give us option 3. You can also do this on your graphing calculator by using y equals. So I just clicked y equals. I'm going to put in 4x squared minus 100. And I'm going to press second graph. So make sure you scroll up and down for a little bit. So I'm scrolling all the way up. I see a 0 under y. So that means one root is negative 5. After I find that one root, let me make sure I scroll the other way. I see another root. I see y is 0 again when x is 5. So that means the other root is also positive 5. So whichever method works for you, those will give you the same answer. All right. Number 4, Isaiah collects data from 2 different companies, each with 4 employees. The results of the study, based on each worker's age and salary, are listed in the tables below. Which statement is true about these data? So for these types of questions, I first like to figure out what are the things they want us to figure out. So they want us to find the median of both salaries, of both companies rather. They want us to find the mean of both companies. They want us to find the range, and all of these are for the salaries. They also want us to find the mean age. So I'm going to change and I'm going to underline salary as well now. Okay, so let's start with the median salaries. So the first thing you need to do when you find the median is list our data from least to greatest. We want it to be increasing. And what's really convenient here is that that's already the case. So in company 1, we have the smallest up here. We go 30, 32, 35, 38. And for company 2, we're up here and we have 29,000, 35,500, 37,000, 65,000. So that's great. It's already in order, which means we just have to find the median. So you're going to cross one off on each side until you get to the middle. But as you can see, we end up with 2 salaries in the middle for both. So to find the median, you add them up. So 32,000 plus 35,000. And I like pressing enter here before I move on. Divided by 2. So the median of company 1 is 33,500. We're going to do the same thing for company 2. We got 35,500 plus 37,000 divided by 2. So the median of company 2 is 36,250. Okay, so is the median salary in both companies greater than 37,000? No, in fact, neither are greater, right? So 1 is not the answer. All right, let's check 2. So the mean salary. And if you recall, the mean is when we actually add all these up and you divide by the number of data points. So we get 30,000 plus 32,000 plus 35,000 plus 38,000. And there were 4 data points, so we divide by 4. So we get the mean of company 1 is 33,750. Now let's do company 2. 29,000 plus 35,500 plus 37,000 plus 65,000 divided by 4. And for 2, we get 41,625. So is the mean of salary 1 greater than the mean of salary 2? No, because 33,750 is not greater than 41,625. So it's also not 2. Okay, 3. The salary range in company 2 is greater than the salary range in company 1. And if you recall, for the range, you're subtracting the biggest and the smallest number. So for salary company 1, it's 38,000 minus 30,000. So the range here is $8,000. The range for 2, let's see, is 65,000 minus 29,000. And we get $36,000. So is the salary range company 2 greater than company 1? Most certainly. 36,000 is a lot bigger than 8,000. So this answer is 3. And by this point, since we're so close, I like to just check my answer for the last one anyway. So I'm going to go ahead and find the mean of both of these. The ages this time. So 25 plus 27 plus 28 plus 33 divided by 4. So the mean age for company 1 is 28.25. And for company 2, add up all 4 data points and divide by 4, we get the exact same thing, 28.25. So one is not greater than the other. They're exactly the same. Our answer is 3. Okay. Question number 5. Which point is not on the graph represented by y equals x squared plus 3x minus 6? And the easiest way that you're going to be able to do this one is to use your graphing calculator. There are lots you could substitute. You could look at a graph, but this is going to be the quickest way, which is definitely important when it comes to taking an exam. So I'm going to type this in exactly. X squared plus 3x minus 6. I'm going to go to the table. So in option number 1, x is negative 6. So I'm going to scroll up to negative 6 and see what y is. Okay, so when x is negative 6, y is 12. This point is on the graph, so it's not our answer. Go to negative 4. When x is negative 4, y is negative 2. This point is on the graph, so it is not our answer. I'm going to go to when x is 2. When x is 2, y is 4, so this point is on our graph, which means this one better not be, and it's not, right? When x is 3, y is 12, not negative 6. This point is not on our graph. Okay, question number 6. A company produces X units of product per month, where C of X represents the total cost and R of X represents the total revenue for the month. The functions are modeled by C of x equals 300 times x plus 250. And R of x equals negative 0.5 x squared plus 800 times x minus 10. The profit is the difference between revenue and cost, where P of x equals R of x minus C of x. So what's the total profit for the month? So this is a very long-worded question, and it's just asking you to do a bit of subtraction. So we know that R of x is this function here. We also know that C of x is this function. So let's write that out. We want to do negative 0.5 x squared plus 800x minus 100. That's R of x. And we want to subtract C of x, which is 300x plus 250. So we are going to subtract 800x and 300x because they are like terms. So we're going to be left with negative 0.5x squared. 800x minus 300x is going to give us 500x, and that's still positive. And then we're going to subtract 100, so negative 100x minus 250. And we're going to get negative 350 there, giving us our answer choice of 2. Okay, question 7. What is one point that lies in the solution set of the system of inequalities graphed below? For this, I recommend graphing all points. So let's start with point number 1, 7, 0. So we go 7 on the x-axis, 4, 5, 6, 7, and we don't go up or down. Point 2, 3, 0. We go 3 on the x-axis. We don't go up or down because y is 0. We got 0, 7, so we don't move on the x-axis, but we are going to move 7 on the y-axis. So 1, 2, 3, 4, 5, 6, 7. And last but not least, we got negative 3, 5. So I'm going to move negative 3 in the x and positive 5 in the y. Now we are looking for the point that is in the double shaded space. And what I mean by that is, you see these lines, we call that shading. So we have these blue ones, and the blue technically, it's going to go over into here too, right? But we don't necessarily care about that, since all we care about is where it overlaps. So we also have these pink lines here, right? Like I said, this is also technically going to go that way, but we don't care because we only care about this space. And the only point that is in that space is this green point we graphed earlier. So our answer is 1. Okay, 8. The value of the x-intercept for the graph of 4x minus 5y equals 40 is. Okay, so here, the vocabulary of x-intercept is really important. I feel like we usually hear about the y-intercept, right? So let me just draw a quick graph here. We have our y-axis, and we have our x-axis, right? A y-intercept is when the point crosses the y-axis. So like that green point there. And let's say that's the point 0, 2. So a y-intercept is going to have an x value of 0. Now an x-intercept is going to be the opposite. So an x-intercept is when the point or the graph, it's going to touch the x-axis. So like that purple point I just graphed. And let's say that point is the point -3, 0. And for all x-intercepts, the opposite's going to be true. Your y value is going to be 0. So all we need to do here is substitute 0 into y and then solve for x. So let's try that out. We got 4x minus 5 times, well, we just said for an x-intercept, y needs to be 0, so 0. That cancels out. We get 4x equals 40. And when you divide both sides by 4, we get x equals 10. So our choice is number 1. Question number 9. Sam and Jeremy have ages that are consecutive odd integers. Okay, let me just pause there and talk about this word consecutive. Consecutive means one after the other. So for example, 1 and 2 would be consecutive numbers. 2 and 3 would be consecutive numbers. 3 and 4 would be consecutive numbers. But this is special. So this says consecutive odd integers. So now they want odd numbers that are right next to each other. So like 1 and 3, or 5 and 7. Those numbers are right next to each other. With just one even number in the middle. So we're skipping the even number. The product of their ages is 783. Which equation could be used to find Jeremy's age, J, if he is the younger man? Okay, so let's say, so Jeremy is J. So let's let J equal Jeremy's age. And Jeremy is younger. So in the examples I wrote in red here, Jeremy would either be age 1 or he would be age 5, meaning that Sam has to be how many years older, right? That has to be 2. If it's the next odd integer up, Sam is going to be 2 years older. So J plus 2 is going to be Sam's age. Okay, and I got to make some space here. So which one of these could represent? We're going to have to multiply this out, right? Because it's asking for the product. So when we multiply, it should equal 783. So we get J times J plus 2 equals 783. J times J is J squared, and J times 2 is 2J equals 783. So we're looking for J squared plus 2J, and that's option 3. Question number 10. A population that initially has 20 birds approximately doubles every 10 years. Which graph represents this population growth? Okay, so we can immediately, the first thing I notice is we can get rid of option 4 because this is linear, right? Linear is when we're adding, not multiplying. And we know we're multiplying because it's doubling. We can also get rid of graph number 2 very quickly because this is decreasing. If it's doubling, it's going to get bigger. It also says the population has an initial value of 20, meaning it cannot start at 0, so it's not 1. Our answer here is 3. All right, question 11. Let f be a function such that f of x equals 2x minus 4, and it's defined on the domain 2 is less than or equal to x, which is less than or equal to 6. The range of this function is what? So this, we can put this in our graphing calculator just to get an idea of what this is going to look like. So we put in 2x minus 4. Let's look at this graph. Okay, so this is a straight line, right? It's going to increase forever. So it's always only increasing or going up. Now let me go to my table now. So when the x value is 2, what's the y value? So we have 0, right? So this line is starting when x is 2, but that means its y value is 0. So we can get rid of 3 and 4 because we know it starts at 0. We just got to see where this line ends now when x is 6. And when x is 6, y is 8. So our answer choice here is 1. All right, we're going to stop at 11:12 for this video. Which situation could be modeled by using a linear function? So similar in the question above, we know that linear has a constant rate of change through addition. Right? So for number 1, a bank account balance that grows at a rate of 5% per year compounded annually, we are going to add 5% each year, but that's not the same thing as adding the same amount. So saying constant would be plus 5, plus 5, plus 5. Once you see a percent, you know that's not linear. 2, a population of bacteria that doubles every 4.5 hours. So when we're doubling, we're multiplying by 2. And while that will be constant, times 2 times 2 times 2, we need it to be constant through addition, not multiplication. If it's constant through multiplication, this is actually exponential. Okay, 3, the cost of a cell phone service that charges a base amount plus 20 cents per minute. And this one's going to be our linear function because every minute it's plus 0.20, plus 0.20, plus 0.20. It's always that same constant rate. Let's look at 4 real quick. The concentration of medicine in a person's body decays by a factor of 1/3 every hour. So this is going to be multiplication or division depending on how you see it. So you're either multiplying by 1/3, so times 1/3, times 1/3, times 1/3. That's the same thing as dividing. So you could say always dividing by 3, dividing by 3, dividing by 3. Either way, it's not addition, so it can't be 4. Okay, so that's it for this video. I'm going to make another video that does the multiple choice questions 13 through 24.